little history that is going to be relevant as we get on later. At one time in ancient times, there were the five planets, the wandering stars that we saw move against the backdrop of other stars. And the word planet literally meant wandering star because we didn't know much else about what they were. Over time, we discovered that we were on another planet. Then the English astronomer William Herschel discovered Uranus, which added a seventh planet. And something didn't seem right about how the planets, particularly Uranus, were moving. And based on that, they were able to calculate that there was another object further out that was affecting how they moved. And that turned out to be Neptune. Well, some people felt, and this turned out to be differences between relativity and Newtonian physics, but they didn't know that at the time. It seemed like Neptune wasn't moving correctly either. And based on that, another planet was predicted. And Percival Lowell, who had built a large observatory out in Arizona, one of the first people to actually go out to a mountaintop to build an observatory. They had just discovered, when he built it in the 1890s, that these kind of positions were optimal to building in cities and in low-lying areas for observatories. He built an observatory there, and mainly to study the supposed canals on Mars, but he turned his attention to trying to find this planet. And he hired a farm boy in his early 20s named Clyde Tombaugh to lead the search. And Tombaugh used a machine called a blink comparator, which compared the two sets of plates taken a few nights apart. And he literally did this for years. Very tedious work. Two sets of photographic plates and for those, especially for the younger members of the audience, these photographs were literally taken on large glass plates, and that's why they were called plates at the time. They and looked to see, it would show you one image, take it away, and show you the other image back and forth, and he'd look to see if anything moved. And when he compared the pair of images taken on January 23rd, 1930 to January 29th, 1930, he saw that this little object had moved here. And he eventually took more images, and sure enough, it was moving at a speed to be a planet in the outer solar system. Now, today we now know that that discovery was a mix of hard work and luck. Pluto turned out to be far too small to cause the effects on Neptune's orbit, and as we applied the principles of relativity to orbital motion, we discovered that there was no need for a planet out there. But in the meantime, we discovered this neat little world, which became the incredibly shrinking world. First, we assumed it was very dark and 12,000 kilometers across. Over time, it has shrunk. Of course, when I say shrink, I mean our estimates of its size have shrunk to around 2,300 kilometers. And that is due to the fact that we assumed it was maybe dark as coal, which is why it was so faint and so hard to see. Turns out it's one of the most reflective objects in the solar system, reflecting away more than half of the light that hits it, and it's very little, but we didn't know that at the time. So it was this largely unknown world for many years, but in the intervening decades after Pluto was discovered, some other things happened. Some major changes happened. Planets had been the province of astronomers for pretty much all of history. And planets were things that we observed through an eyepiece or through photographs taken from the ground. But in the 50s and 60s, we began to actually explore them. And the first spacecraft to image another planet close up was the Mariner 4 spacecraft, launched in 1964, arrived on July 14th, 1965, which incidentally would be 50 years to the day before New Horizons would reach Pluto. And it would take these pictures of Mars, showing it to have craters and other types of linear features we didn't know much about. But for comparison, I put a telescopic picture of Mars taken on the same day. So as you can see, we could see a lot more. And the planets became worlds to us. One by one, we explored. This up here, these are both Venus. This is through a regular camera that could only see the atmosphere, and this is ultraviolet in this case to see more detail. And this is a radar map that shows the surface. Mercury and its cratered surface, Mars relatively close up, Saturn, Jupiter, Uranus, Neptune. One by one, the planets all became worlds that we could actually see and touch. We even sent landers to Mars and Saturn's moon Titan and Venus and of course the moon. These planets have all became real worlds to us. And meanwhile, Pluto languished. The famous Voyager mission that explored many of the outer planets, of Jupiter, Saturn, Uranus, and Neptune. One of them could have been targeted to Pluto, but that would have meant giving up looking at Saturn's moon Titan, which is the only place in the solar system we know now has liquid on its surface that's active, other than Earth. It turned out that it couldn't see much because of the haze that it wasn't equipped to see through, but it seemed like a good idea at the time to see Titan. So Pluto remained unexplored. It so happened that in 1978, the first real advances happened in our study of Pluto. In the late 1970s, I should say. First, it passed in front of a star, and we discovered, by watching the light come and go, that Pluto had an atmosphere. We also discovered, an astronomer named James Christie discovered that in photographic plates, there seemed to be a lump on one side of Pluto periodically, and then sometimes the lump would disappear. And it would do so in a cycle of about a little less than 7 days. Now, Pluto is a tiny point of light in this. My laser pointer is probably about as big as Pluto is, but blurring of the picture keeps us from being able to see that. And so it wasn't clearly something hanging off of Pluto. And what we finally discovered was that Pluto had a moon, a really big moon. And that moon was named Charon, or sometimes you will hear Charon. The naming is rather interesting, and the pronunciation is something that we debate, because his wife was Charon. Charon is the proper pronunciation of the mythological figure that it was named after, but he always called it Charon. And so there was actually still debate among the team during encounter, actually. Should we say Charon and should we say Charon? Or should we say Charon? I grew up saying Charon, and so that's what I do. And it was discovered, and I'm going to have to back up after I do this, that Charon would be passing in front of Pluto in the mid-1980s. And that allowed us, by measuring the amount of light that it blocked off from Pluto, to construct these crude maps of Pluto's surface. So this is all we knew. On one side, we were able to map it pretty well. Same with Charon. On the other side, not so well. Because that brings us to another strange aspect of Pluto. Pluto and Charon could be described as a double planet, in that, unlike anywhere else in the solar system, they actually Charon is so big relative to Pluto that they actually circle around a point outside of Pluto. And also, they are tidally locked to each other. Now, the moon is tidally locked to Earth. That's why we can only see one face of the moon. Well, we can't see the far side of the moon from Earth. We always see roughly the same hemisphere because we're tidally locked. But they are tidally locked to each other. So if you lived on Pluto and you lived on the wrong side, you wouldn't know Charon was there. If you lived in the other side, it would always be in the exact same place. We also discovered that these bright and dark markings from the mutual event images were extreme. Most worlds that we don't have, most worlds don't have nearly as much contrast. Also in the late 1980s, when Voyager encountered Neptune, it encountered a moon called Triton, which is roughly the same size as Pluto, and had lots and lots of interesting features, including a large polar cap, this terrain here that is called cantaloupe terrain because it looks like the surface of a cantaloupe, and a thin atmosphere, and lots of things that are very difficult to understand. Very interestingly, we discovered these little geysers that are erupting out of its surface, which was a real shock to think that a world outside could be active. So after the Voyager encounters, Triton, this was roughly what Triton versus our best maps of Pluto and Charon, and with their approximate color. And so there was temptation to think of it as a more contrasty Triton. But we really didn't know. Another very groundbreaking discovery was that, and these distances are not to scale, was that we began to discover more objects out here near Pluto. So Pluto had been this oddball at the end of the edge of the solar system that didn't have any other objects like it. We discovered that there were hundreds, maybe thousands of smaller worlds like it out there. So we realized that rather than being this lone sentinel on the edge of the solar system that had been since Tombaw's discovery, it was actually the brightest, perhaps largest member of another region. Problem was, in studying it, other than those maps that we weren't sure of how accurate they were from those that we made in the 80s, this is the best map that the Hubble Space Telescope could make. Made this in 1994 when it started. You can definitely tell that that there are lots of markings there, but you really can't tell much about them. And the image that I put up here is one of what the actual photographs to make this map looked like. So that brings us to men named Alan Stern and New Horizons. There had been many plans to build a spacecraft to go to Pluto that had come and gone. Most of them had died in budget cuts, and it's very hard to sell a mission to Pluto because it's expensive to get out there. We didn't know how interesting it would really be, and it takes many, many years to get there, and if you don't want to take decades to get there or have a really, really large, expensive spacecraft, you're just going to be able to fly by it over a few hours because you're going to be going so fast that you're not going to be able to stop. You're also going to really have to make compromises in terms of the mass of the spacecraft. And most of these missions didn't do that. And to quote Alan Stern, what he realized is to get 90% of something is better than to get 100% of nothing, which is what missions had been getting. So the design of the spacecraft And I want to thank Paul Falk, who has come, and I'm going to pass this around. This is a 3D printed model of the New Horizons spacecraft. This is the antenna. The instruments are here. This is a long-range imager. This in the back is the nuclear power source. And incidentally, although this actually used Russian plutonium because we had shut down our plutonium production and we're making it from Russia, for future missions, the plutonium is being made right now here in Oak Ridge. So it's a little local connection. So I'll start this around here. Don't break it. You can't trust Professor Cobb, sorry. So New Horizons was designed to get us to Pluto in 9 years. You may notice on my shirt this patch, you probably can't see, but it has 9 sides. 9 years to Pluto, Planet 9. Now many of you all are probably thinking about the planetary status controversy. This hadn't happened yet. So, Planet 9, and 9 with a recurring theme in the mission. It contained 4 instrument suites. PEPSI is a particle and field instrument that studies magnetic fields and solar particles and how they interact. And SWAP also looks at solar radiation. LORRI is a long-range imager. It's a high-resolution camera that can take pictures from a long way away. They're only black and white, but it can see things really, really well. The Student Dust Counter, which is the first mission on first instrument on a planetary spacecraft that, oh, okay, well, they're taking pictures through it, but that is, everything okay? Sorry. So the Student Dust Counter is the first instrument that was designed and operated by students, so mainly graduate students. Of course, the one kind of sad thing is that the students who designed it and operated it and prepared it were not the same students who got to use it during encounter, and now new students are analyzing the data because students are, of course, transient. But it gave a lot of them experience working on a mission, and a lot of the alums came to the encounter anyway. Of course, some of the original people, a few of the original people were actually scientists working on the mission by the time we got there who worked on building it. Ralph contained a color camera as well as a spectrometer to study the composition of the surface. And Alice is an ultraviolet spectrometer, which was to study the composition of the atmosphere of Pluto and to look for an atmosphere around Charon. So that was the instrument suite. The big thing that disappointed a lot of people is the lack of a magnetometer. And the reason is because spacecrafts have their own magnetic field, so it would have had to have been on a large extension from it, and it would have just been too expensive. And trying to do that killed a lot of earlier proposals because it just made it too expensive. Another thing about New Horizons, it could have, if we wanted to wait 20 years to get there, or have fewer instruments, we could have all the data on the ground now with a bigger antenna. But as it stands, we have about half the data on the ground now. It's still transmitting data from last August. And the reason is because what was decided was that, it doesn't really have anything really high priority to send back right now. It is doing some distant studies of other objects in space, but it doesn't have a lot to send back. So let's get there quicker, make the spacecraft lighter, send data, can get a picture or two a day. It's a lot slower than a 56K dial-up modem. But I can get a picture or two down a day or another data set and slowly get it down over a year and a half, but get there faster. So it was a compromise made. So on its way to Pluto, after launch in 2006, it would fly by Jupiter. and these are some pictures of, these are actually two separate pictures. This is Io, Jupiter's moon Io, and Jupiter itself. This is Jupiter's moon Europa, where our next big outer solar system mission is going, and Io with its active volcanoes that you can see here. So it did a lot of science actually at Jupiter on the way. And this is the image that I worked on of Jupiter's moon Ganymede that it took, and this was my first contact with the mission. John Spencer, who was a deputy manager, basically a deputy investigator for the deputy principal investigator for the long-range imaging camera, asked me if I would take a look at it and see what I could do with it. So that was the first I heard myself from the mission. And so I thought I'd throw that in there. Then came the bombshell in 2007, or in 2008, 7 and 8, the International Astronomical Union's demotion of Pluto. Now, a lot of people have strong opinions, and I'm not going to take a side in this. However, I will take a side in the way that happened was odd. The International Astronomical Union basically sets rules for naming features on planets and other worlds, and naming stars, naming other things. This helps immensely in the sense that, you know, people, for example, explore the solar system, you know, China, Russia, all through Europe, India. And it would be very confusing if we all came up with our own names for things. And like any scientific field, you know, the same thing would go for plants. You know, if every, you know, while plants have their common names, if there didn't have if every agency and group that studies plants had their own individual scientific names for plants, it would be really confusing. And so that's what the International Astronomical Union does. Well, Pluto was not on the agenda. There were about 3,000 people at this meeting. On the last day, when only 400 people were left, most of the people were in this group because they knew about it, they just didn't tell anybody. They announced that they were going to, they opened the issue of what is a planet. And many proposals went around, but they created a very unsatisfactory system that I think will be, I don't know that Pluto will ever become an official major planet again. But it will, I think that there will be some changes because they decided it was in a new category. There would be 8 planets, and then there would be dwarf planets which would not be considered planets. That's really easy to explain. It's a dwarf planet, but it's not a planet. That was supposed to simplify things. And they had requirements like clearing an orbit. Well, Jupiter even has things, the largest planet, that share its orbit. So, and Earth has things that share its orbit, so what exactly that means is questionable. And what I think we really get to with the planet controversy is this. The first thing I said was that the planets were originally the wandering stars. Planet is a pre-scientific term. And we have, we've done in many cases, we have tried to, jerry-rig it into a scientific term. But it is problematic. I mean, the Earth is, about 12,000 kilometers. Pluto is 2,000. But we have, the Earth is a world like Pluto with a solid surface and an atmosphere above it, clouds, geologic processes. Jupiter is 318 times the size of the Earth, doesn't have a solid surface, mostly a big ball of hydrogen and helium gas or liquid if you get far enough down. Which one has more in common? So, I think what we really run into is names, to some degree, are things that we give to things that exist so that we can communicate with one another. And the universe doesn't take care to fit things to our relatively arbitrary names, and that can run us into trouble. And so I've put up this slide of, this is one of 2 slides that I actually changed today because of I'll show it in the very last slide too, something related to this, because of a major discovery that was made. The dwarf planet Makemake has a moon, which is called MK2 there, that we didn't know about. Now, this graphic does show the worlds and then them with their moons, so that they're not actually all double like that. But these worlds are the dwarf planets. The discovery of Eris was what set off this whole demotion thing. Eris was thought to be larger than Pluto. It's technically not. We now know it's not, but it is more massive. So finally there was another world out there the size of Pluto. But Pluto is just one of these many worlds. And what's interesting is they're very diverse in color, but we know very little about the others, and so there's a lot more to explore. But their sizes here are relative to the Earth and Moon, and so it gives you kind of an idea of how they compare in terms of size to more familiar worlds. But Pluto is the largest. I will add too that if you count Charon, the Pluto system is the largest center of mass in the solar system that had not been explored, because Eris does not have a large planet-sized moon. So, I'm going to shift gears now and talk about some work that I did. I have always been interested. I think I became a philosopher because I didn't know what I wanted to be when I grew up, and I never really settled it out. I've always had many interests, and one of them has always been as a planetary astronomer. It's been planetary astronomy. When I was a kid, I loved working with telescopes and stuff, and I loved working with pictures either that I took or scanned on my computer, and I have throughout my life been interested in that, and some of them have been published various places, and I also shared a lot in online forums. And in the fall of 2009, I got an email from Dr. Alan Stern and Hal Weaver, who were some of the leaders of the mission. The mission really is Alan Stern's brainchild. And I thought that it was probably from some mass email list. And it was an invitation to come present about my work on Neptune's moon Triton. Remember the one with volcanoes and such? To the New Horizons team in January 2010. And I remember asking my wife to come read the email to me because I was sure that it was either somebody playing a joke on me or I was misreading something or had been said to the wrong person. And before I got excited, I wanted to be sure it was real. But it was. And so I prepared a presentation and went, and just to show some of the work I did. This is the typical version of this image shown, which, because of motion of the spacecraft, these color features are not real. They are due to the fact that the Voyager did not have a color camera as we know it. It took pictures through different color filters, black and white pictures, that were then put together to make color. And the spacecraft moved while they were taken, and therefore they're out of alignment. There's a lot of instrument noise. This part is cut off because it was smeared. I did some desmearing processing, and this is my cleaned up version. A lot less like a kaleidoscope, but also a lot more like Triton would actually look. And these are some of the features where it looks like there's some calderas that have erupted volcanic nitrogen out onto the surface. Little impact crater there. This is a frozen nitrogen lake that it photographed. That's the cantaloupe terrain close up. And some more of the views. This is kind of a bridge between the lakes. And finally, you can see some little clouds up here as it was leaving. So I presented this work, and the presentation went very well. There's the full disk of Triton from my reprocessing. And there I am in 2010 presenting to the New Horizons team. And that was one of the, I don't think I've ever been that nervous. So, meanwhile, Pluto, this map of Pluto was actually shown, which was the best map at the time. Basically, the difference between the map that you had before is that this is in color, but still very ambiguous. And the main thing that was going on at this meeting was planning for the New Horizons flyby. And as you can see, despite 9 years to Pluto, this happened very quickly. You see, this is 6 hours, 6 o'clock, 7 o'clock, 8 o'clock, 9 o'clock, 10 o'clock, 11 o'clock. Very quick. And you had to have a trajectory that would fly by Pluto, and also it had several little moons that were minor moons that were discovered. Get a good view of everything. See Pluto, see Charon. Go behind them through both their shadow for the Alice instrument to study the sun's light, and as well as for the radio antenna, for the radio waves to go through Pluto, its atmosphere, and study its composition, as well as Charon. Incidentally, it did something that we didn't expect it to. It bounced radio waves off of Pluto, and we were able to pick them up on Earth, and so that we should get some good science out of that, but that's still being analyzed. But we also, because we discovered all these moons, we were scared that we would discover more and more and more and more as we approached. So we developed what was called the Shabbat Trajectory that would have taken us way out here somewhere and kept the cameras aimed correctly, just in case at the last minute we had to divert and not fly by Pluto, because had the spacecraft failed, had it hit something, remember, we're still sending data back. That data would have never been sent back had it not made it through. So, in January of last year, we had our final pre-encounter meeting. The Clyde Tombaugh family came. That's who they are. And that's Building 200. I'm sure you're familiar with it. That didn't exist when I started working with this project, where we would be headquartered. And we made our final on-site preparations with the whole team. We had several other meetings, but this was the last time we got the whole team together. And then in June of last year, we got there and we started setting up. That's Maria Banks, one of the people who worked with the mission, and she and I were working on setting up some of the computers and getting some of the stuff ready. And there I am creeping into the auditorium where they did the press conferences, doing a selfie in there while I still could. That was the one place that we actually could freely take pictures. They had a place where they kept the press.
Where is there?
Oh, sorry, John Hopkins University Applied Physics Laboratory. I apologize. I completely forgot to mention that. Yeah, sorry. It's the Applied Physics Laboratory in Columbia, Maryland, essentially Baltimore, outside of Baltimore.
Where was that building in a previous slide?
That's the building we're inside. That's at Johns Hopkins, at the Applied Physics Laboratory. I actually thought of that as the golf building went up. I was like, oh gosh, it's amazing how similar the building is inside to the golf building, except that it has normal lighting. So, anyhow, as we approached, we got better and better images, and we'd come in and we'd ooh and ah. There we are set up, and if you notice, each of the team had our little areas. Why isn't this? Sorry. Oh, I got the pointer upside down. We were here, and then atmospheres, particles, and plasma and composition. It was organized differently. I found this interesting than a lot of teams have been organized in the past. Is in that, like for example, Voyager, there was imaging science, there was the infrared team. It was all divided by instrument. But the fact of the matter is that for geology and geophysics, there were, and for atmosphere, then for everything except really plasma and particles, for the other three, we overlapped so much that we weren't all getting information from one instrument. So that's why we were kind of blended together like that. So, and as it came in, we began to have press events. And wait, there I am at the big press gala. There's Ellen Stern and Glenn Fountain, who was the project manager. This is now across the street from where we were, where we were all meeting, where we kept the press during the encounter. We all took turns with doing the 9 symbol, doing 9 with our fingers. These hats were actually Green Bay Packers cheesehead hats, that we made up to look like the spacecraft, and so that was a lot of fun. So, as we approached Pluto, the things became very, very orchestrated because we had a problem. The antenna is rigidly mounted on the spacecraft, which meant that while it was actually taking observations, it couldn't send information back. And given that it was only close to Pluto for a few hours, we didn't want to waste any time sending information back. And so the problem is, of course, the press came on encounter day, and they wanted something to see. So NASA, and this infuriated us, we were supposed to get our first pretty good picture. It was kind of our security picture, sent back. It was called P. Lori full frame, which Lori was the instrument, P was for Pluto. It was to be the first good picture, really good picture that showed us what was going on, and also one that would be useful if the spacecraft failed, if we never heard from it again, if Pluto was surrounded by dust that it hit and we never heard from it again. It was also set up as insurance, and we were supposed to get it at 11 o'clock the night before the encounter, but NASA ruled that we couldn't look at it, that it would be recorded and not looked at, and instead we would all have to come on encounter day, not that it wasn't going to be a long day anyway, at 5 in the morning, and see it on the screen all at the same time. Part of this was so that it could be encounter day. Another part of it was this. Unlike encounters of the past where people really did gather around monitors for everything, we all had our laptops, we all had direct access to the pipeline, so a lot of the time we were all sitting in different corners of the room looking at things, which in terms of being able to get a good look at the picture is far better. For photographers trying to document it, it's a nightmare because they can't see the interaction between people and stuff. So they basically made us all go into a room together. And so the image came down, and this was it. P. Lori full frame. And it was shocking, this heart-like feature, which is, this part of it is called Sputnik Planum, but the whole feature together was called Tombaugh Ratio after Pluto. But all these kind of funny little furrowed features, this area where we couldn't really even make out what was there, it didn't disappoint. You know, we were afraid that it would be some featureless, something just covered with impact craters because nothing had happened there for billions of years. It turned out not to be that at all. And there we are at the moment we saw it. I think I'm visible in some of these. Yeah, there I am. But these are some sequences of our reactions as it came down. And I had to do a selfie there, and that's how it looked on the screen. And that was actually I actually wasn't supposed to be taking that, but I saw that everybody else was doing it, so I figured they're probably not going to kick all of us out. And so it was a exciting moment, and it really seemed surreal. Meanwhile, the press had crowded into the building across the street, and as well as the public, and were excited to see it. And meanwhile, the leaders of the instrument teams and Ellen Stern gave a conference. give a press conference to show off the image. And when we got the there we are again. There I am with Ellen Stern actually that day, and we kept doing the little presentations, trying to keep him busy. And at the end of the day, we got the signal that we had got a signal from the spacecraft knowing that we had made it. And that's when we cheered. And the flags, the reason we had the flags, these were actually the reaction was a little disappointing for some people, because what Alan remembered is that when Apollo 11 landed, people had in the auditorium those flags and they waved them. And it was to harken back to that moment. But what he didn't count on is that for the younger members of the audience, that connection, the Apollo connection, was totally lost. But still, it was a lot of fun to wave the flags. I had, and those of you who know me will be unsurprised by this, I had an incident that day. On the bus that took us, it was between the buildings. It took a hard turn, and I actually fell out of my seat on the bus and dislocated my shoulder and managed to reach around and get it back as it should be. Some people were trying to get me to go to the hospital. I would not. I was thinking, okay, I have worked my whole life to be at this moment, and I am not missing it, even if I have to hold on to my arm the whole time to not be in the hospital today. As a result, I'm not found in many of these pictures from this moment, because I was kind of hiding off in the corner where I could kind of prop my arm against a wall, because I couldn't lift my right arm. And I didn't want to be I could see myself becoming an internet meme or something. You know, look at the unpatriotic guy who's holding their flag down. Yeah, he must hate America. I was like, no, I just hurt my arm. So I kind of positioned myself not to be embarrassed.
What's the signal transmission time?
It was about 4.5 hours one way. So 9 hours to get a signal there and back. And you know, that was actually probably one of the most helpless feelings for us on the team, in the sense that knowing that it had already happened but not being able to verify it, so there was literally nothing that could be done. You know, some people wanted to look back through sequences, through code sequences and such, and Alan and others said, you know, don't do it because you're just going to stress yourself. You know, you can't do anything about it. This has already happened. And it really gives you an interesting sense of what time is, that literally it's divided, you know, you're 4 hours away, and literally there's no way of knowing until those hours pass.
What are you doing between
That and mainly dealing with the press. I did several interviews, and other people did. So once we were back in communication with the spacecraft, basically it was images coming down little by little, learning more and more, and lots of people reacting as we got to see what Pluto looked like. And these images, we still really don't know what's going on here in the bladed, sometimes called snakeskin terrain. We got this nifty image. This is Pluto and Charon with correct brightness differences separated by the real, like this is the actual scan, not a montage. And then this is a different picture down here, a close-up of Pluto. But we started getting these images down, and we eventually got to see what Pluto looks like up close. It has these mountains that are 11 kilometers tall, and we still are trying to work out what kind of ice we're figuring they must be water ice, because that's the only kind of ice. Water ice is essentially a rock by the time you get to Pluto in terms of hardness. What could support itself that tall? We found this smooth area with almost no topography called Sputnik Planum, and we don't know why. It may be an old impact basin that's been developed. These dark areas this is called Ktulu Ratio. Those of you familiar with J.P. Lovecraft know it's the evil monster in his books. We don't really know why that. We know that there are different materials deposited there, but we don't really know why. And this terrain with lots of canyons and cracks, and so a lot of these features, honestly, looked more like Mars than Triton. So it really began to surprise us. Now, as these images came down one by one, we had to resort sometimes to very primitive techniques. For example, people wanted to see this this mosaic, and we weren't quite sure on some of the details to put it together. So we just printed out the pictures, we cut it up with scissors, and then we put it together. We taped it to the wall to put it together, which is how they used to do it, back in the 60s, 70s, and 80s, is print the pictures out. So it actually kind of connected us to the past in terms of how we did it. By the way, in case you're wondering about this little upside down map here, the text being upside down, Pluto, we were primarily looking at the North Pole of Pluto, and we were primarily looking at the South Pole of Triton, and we were wanting to compare the polar regions 1 to 1 so that we could compare them at similar angles. We turned the map of Triton upside down. So another thing that surprised us was Charon. It was pretty much accepted that Charon was going to be a boring world, just impact craters, nothing else. And the significance of impact craters or nothing else is that if there's nothing but impact craters, that means that nothing has happened on the surface to erase impact craters, which means you have an inactive world. And it turns out that while it does have impact craters, it has this large cliff system that goes all the way across it, and some interesting little linear features that we really, again, are only beginning to understand. This dark region at the top that is colored differently, we call it Mordor. That's what we're calling it. I'm sure you recognize the Tolkien allusion, but they're white, and that centers on the North Pole, and we're not really sure why. But it does. So these are two different sets. This is Pluto versus this is Triton. So as you can see, very different. Pluto is much more contrasty, has much bigger features, much more topography. Triton, the features tend to be smaller. And the hypothesis we have now is that when Triton was captured by Neptune, and we know it was captured, that it didn't form at Neptune, because it orbits in a retrograde manner. In other words, Neptune rotates in one direction, it orbits in the other direction. There's no way it could have formed like that. And so it probably was a dwarf planet itself one day, and the capture would have melted it down. And it probably never redeveloped intense topography like Pluto has. That's what we think. This is a false color picture from the Ralph instrument that looks at it showed us early on that the surface was extremely varied in composition. We're only now beginning to discover the significance. Many people called 2015 the year of the dwarf planet because it so happened that another spacecraft called Dawn reached Ceres, which is the only object inside of Neptune's orbit that's considered a dwarf planet. And Ceres was explored the same year. And these in relative size. In comparison, Vesta is the largest asteroid. So that gives some relative scale. We began to explore the small moons, Nix and Hydra. And I remember I was the one who originally worked with this and started to notice that this kind of almost looks like a tooth or something. And we also noticed there's a strange little red spot on Nix, and we still don't know why. We know it corresponds to a crater, but why it's red, because none of the other craters on Nix are red. So as as time went by, we also started to get images, and we debated even whether to take these images looking back at Pluto and Charon afterwards, because we were looking at the sunlit hemispheres as we approached, so we were now looking at the night side. And we figured we might get some information from Sid and Crescent, so this image of Charon came down. And sure enough, we can just barely see a little detail. So we thought we'd get the little image of Pluto, and we saw this. Like, what? It turns out that its atmosphere, its haze, extends out so high and so far that not only did it totally overwhelm the little bit of Pluto we can see up here, but we could see it all the way around. And we had never imagined that the atmosphere would scatter so much light. Here is another view. Unfortunately, with the light in here, you can't really quite see it go all the way around, but this is before we had gotten at such an angle, and you can see a lot of the same features we saw approaching, but that are backlit. And you can see the haze going around. This haze has all sorts of layers to it, and we're trying to analyze why. Look for individual clouds and plumes. By the way, this is Sputnik Planum versus the area around it. This really accentuates the difference in topography, I think, this illumination. And so for a while we didn't get much more data back, but as we did, we got more images of all the little moons compared to Charon. Got a really good close-up of Nix, which showed it to be very irregular, very cratered. A big surprise was that we were able to see and map some of the areas of Pluto that we shouldn't have been able to, that were not lit during the encounter. And the reason is, remember that big unexpected haze? Well, just like twilight, scattering light in the Earth's atmosphere, means that when the sun goes down, it doesn't immediately get pitch black, dark. That haze was our friend and lit up some more territory that we were able to map that otherwise would have been missed. And we began to look at these big chasms and pits that exist. Maybe they're just pretty to look at. All over the place. We began to get our really close-up imaging. This gets down to about the size of a football field, not stadium, but the field in terms of what it can see. Really a little smaller than that. And we discovered in these areas that there are actually active nitrogen glaciers that are actively carving these and moving towards Sputnik Planum. And we don't really know exactly how it is that they can exist, but we have observed them, and we can see some of these flow patterns as they, just like glaciers on Earth and Antarctica and Greenland, as they flow into Sputnik Planum. So that is a major discovery. We also discovered this feature, Right Mons, which is a volcano. We don't know if it's active or not. And this is an elevation map of it. Also, this one, Picard Mons, was discovered, and I know I turned this sideways at the last minute because I realized it would be hard to see. Turn the other way. That's in the twilight area that we would have totally missed. Some of these little islands that float, we've just in some of the more cratered areas versus those islands. Just all sorts of features. We also did compositional mapping. This looks at the distribution of methane ice across the surface of Pluto. Here's a close-up, and we see that around some of these crater rims, there is more of it, and we think that it's being dug up and then removed by some sort of process. There are features like this, we call it the spider web, that we're just really not sure what it is, but it really is cool to look at. We have begun geologic mapping. And we've mapped the fractures in Sputnik Planum and different types of terrain as we try to analyze what is going on. This is a far better data set than we've had of a world in the very outer solar system, but we don't have a lot of context, and so trying to understand what's going on is the challenge of the day. We're also working on global mapping. We have provisional names. They're not official yet, but a lot of them are after like Pioneer Terra, Voyager Terra, Venera Terra, Lowell Regio. They're after either astronomers or past spacecraft. And you might notice the inequality. One downside to a flyby is that you only get a really good view of one side. We'll get a bit better view of this, but not a lot. Why we need another mission. There's Sharon. Again, global map as we stand. And so New Horizons is now continuing to head out of the solar system, and on the way, it's heading, if it's approved, it hasn't been approved yet, but we'll know this year, it'll be flying by a small Kuiper Belt object that's about 60, 70 kilometers across, called 2014 MU69. We're thinking of naming it Jim Green because Jim Green is the person who gets to make the decision of whether we get funding or not. So we think that that might be the thing to do. We've actually discovered in a specific search done by the Hubble Space Telescope looking for something to fly by. And this was in the original mission proposal to do this, but it's more important than we thought. Because we thought with Pluto's small moons we'd get some idea of what small objects in that part of the solar system were like. But there turns out to be a problem. You know, Pluto has that big haze. It has, or at least has had, volcanic activity. And unlike any other very small world we know of in that part of the solar system, its moons are extremely reflective. And that's because Pluto has coated them with bits of it. And if you're trying to study what they're made of using spectrometers, that's a problem when you have a world coated with parts of another world. And so we're going to get to see a pristine Kuiper Belt object. A big problem, incidentally, in finding something to fly by is that Pluto, as seen from Earth, is passing right against the backdrop of the Milky Way, which makes for pretty pictures, but that means lots and lots of stars, which makes it really hard to pick out faint little objects moving around. The good thing is that we can do that with computers now. We don't have to do something like Clyde Tombaugh did, sitting there hours and hours and looking. So, some things kind of wrapping up. This graphic, I think, kind of gets it. Pluto had a heart, the heart-shaped Tombaugh ratio, and that kind of personified it. You know, Pluto, poor little Pluto, got and an almost broken-looking heart. And you know, then there was poor little Pluto that finally got an encounter. Another bit of a personal highlight. You know, as you might imagine, being there between things coming down and things to do, we had some breaks. And we'd go out. Really got an addiction to Chesapeake Bay crab that I don't know how I can permanently break. I have no way of fulfilling it either, except when I go up there for team meetings, but most of them have been in Boulder, Colorado since, because after spending that long there, nobody really wants to go back until we have to. But one night, we went out for ice cream in Annapolis, Maryland, and there was a girl in the ice cream shop who saw us, because we were all wearing our team shirts, and was like, "Are you all the Pluto people?" And she was so excited, and she talked about the class project she was doing and how she wanted on Pluto and how she wanted to be, she wanted to study the solar system when she grew up. And, we really made her night to run into us in the ice cream shop. And there I am there looking like a deer in the headlights like I usually do in pictures. But that was just it was really neat, you know, to get to provide somebody with that kind of experience. You know, will we ever go back to Pluto? I hope so. I'd love to send an orbiter, another flyby. But there's lots of other objects out there that wait to be explored. Makemake, named after one of the gods of the people of Easter Ireland. We've just announced the discovery this week that it has a moon. Kind of Alex Parker processed this image. It explains, what we're studying is to try to figure out how common it is to have a lot of moons. Pluto has more moons right now than any other object in this part of the solar system, but part of that is because it's been looked at more. And incidentally, that was one of the biggest strange things, is that Pluto didn't have any moons that we hadn't discovered from Earth that we could see with New Horizons. But so this was a most recent development that I added at the last minute. But Pluto, whether you want to call it planet, dwarf planet, Pluto magnificent, I don't know. What we know is it's a fascinating world with lots of activity and features that have a lot to tell us about how worlds develop, of how our solar system develops, and things that we could have really not imagined. It really shows us a place where we're now trying to answer questions we would have never thought to ask. And I think that's what real scientific discovery does. It doesn't just give us answers, it gives us new questions. It gives us the questions to ask that we would have never thought to ask. And it has really just been a highlight of my life to be a part of the mission of this little spacecraft that could, which, is really pioneering a region of the solar system. Any questions? Yes?
It's really exciting. When there's a New Horizons Junior or 2, what do you want to
Please.
see? Do you want to see a starlight camera that takes a picture of the backside, or terahertz radiation, or magnetometer? What do you want your favorites?
Well, I don't think a magnetometer is a key priority because from what we've studied, there's not enough metallic to it. That it's very, and based on the indirect measurements, studying the solar wind around it, it's with the Pepsi instrument, it's very unlikely. But in terms of seeing the backside, the problem is you could probably do that with an orbiter. They could take very long exposures. The problem is we're moving too fast, and such things would smear. We have tried to get images from the light reflected from Charon on it, and we've been able to actually detect Pluto's surface, but not much else so far. A big problem is, if you probably experienced, if you've ever taken a picture with where you're looking into the sun, there's a lot of glare. So these images are really hard to process, and any instrument is going to have that problem. If you have a really sensitive instrument, point it right back at the sun, you're going to blind it. So, but trying to map the rest of Pluto, as well as just the rest of the part that are lit. Also, clearly you have an active atmosphere, active surface processes, seeing what's going on. I'd love to see an orbiter or another flyby. I'd also like to see a flyby, maybe going by Uranus or Neptune to target it, because their gravity could be used to target a mission to explore Makemake and Eris and Sedna and some of those instruments out there. I probably lean, much as I would love to see Pluto again, to wanting to explore more worlds, and so that we can put it in context. Because the only world we have to put Pluto really in context is Triton. And Triton, because of its unique situation of being melted down, we don't know. Was there another part to your question I didn't cover?
There were more questions. One might be that, given the time it takes for a mission, and given the events following up from April 12th, the Starshot breakthrough funding, year of military, it's possible that there'll be 10 missions to Pluto, little solar cells and missions powered by lasers. So, do you think this is going to be a big breakthrough?
Well, maybe. Again, we'll see. If there have been lots of proposals for different missions, and whether they materialize or not, we'll see. I hope so. And there was actually a proposal while we had the development teams in place to build a New Horizons 2, but it wasn't funded, so it didn't happen. Yes?
The teacher in me wants to know, are any of these images available on NASA's website?
Yes, a lot of them are. And so, yeah, a lot of them are. And also,
Close-ups?
Yeah, and there's actually a lot more. I couldn't show all of them. So yes, if you go to, I wish I had a way to show you all our website. The New Horizons one that's hosted by the Applied Physics Laboratory at JHU 8PL. That one has the best in terms of imagery.
Pluto.jhupapl.edu.
Yeah. Thank you, pluto.jhuapl.edu.
Wait a minute, JHU.
apl.edu. Thank you. I couldn't remember if there was something in after. Yes.
I missed something in the beginning. Exactly what was it that drew NASA's attention to you with that email and everything? There's something.
I summed over that I had presented some of this work at the Lunar and Planetary Science Conference in Houston, Texas in 2008, and some people had seen it who worked on the mission. And I didn't realize that, and I'd also posted some of it on the web, and some people were working with the same imagery, and they were interested because of the results I was getting, and that's why they wanted to talk to me, and so that's what I've been working on, particularly with the small satellites, is doing similar image processing. It's one of the things I've been working on with those pictures.
You said they couldn't figure out what the composition of the planet is, especially the hard shapes.
We haven't figured out exactly how the formation. We think it's probably water ice there, but again, figuring out what's underneath versus what's on the surface, we're still trying to settle out. There's also we can detect a lot of methane ice. There's some carbon dioxide ice.
It's smooth desert-like surface. It's very interesting.
Yeah. It kind of reminds me of some areas of Antarctica. So yeah, I thought it.
And how's that relate to where Charon is?
It is on the anti-Charon hemisphere.
So we haven't seen images from the Charon side?
Yeah, not close up.
Are there any other considerations for the flyby of the next object other than budget?
Beyond that and sheer interest, what we would like to do is, if we can't orbit something, we would like to see more than one. And so finding worlds that are in a good place to do a flyby of more than one object in a single trajectory, as well as maybe being able to pass by Uranus and Neptune, which could target us. Basically, if this is the spacecraft going out to Pluto, to wherever it's going, if it passes by Neptune, and it can curve its trajectory to basically pass sideways through the Kuiper belt instead of directly out through it, it's going to cover more area and then thus be able to encounter more objects. And another thing is the development of nuclear electric propulsion. If that ever gets funded again, that would allow more maneuvering out there when you got there, rather than having to use hydrazine propellant that is very limited. You have a very finite amount of delta V that you have to use sparingly, because it's based on how much fuel you have in a tank. But one of the most interesting ones, there's one called Haumea that we know is spinning so fast that it's elongated. We'd like to study. Eris, just because it's near the size of Pluto, but Eris is so far away that it's an unlikely candidate.
Can you tell them something about what started you into this, the Soviet images that you...
Well, actually, the thing that really got me into this, I mean, it would have probably been a passing childhood interest, but it was actually the Voyager mission passing by Neptune. And, it was the last encounter of a great mission. And I remember going and buying the newspaper every day, hoping that there would be a picture. I'd ride my bike down to the convenience store and also go to the library to see whether there was a picture in any of the magazines or other newspapers, and trying to follow it. And there was a program on PBS that night called Neptune All Night, where they showed the images live. And in looking at those, and watching that, you got to see these images come down live. At about 11 o'clock, my mother told me I had to go to bed. And when I said, but they're showing a new world on TV with Triton, and she said, well, you'll thank me for this someday. Well, no. But my reply to her was, I'll be there next time. And I guess I was there next time, the next world out that we explored. So that got me into it. And I guess the other thing that first got me interested at all, this is kind of funny, the really, I don't know if you've ever seen them, these really bad early 80s images of Saturn that were false color, that looked psychedelic. And I saw it in my textbook. If I'd known I was going to talk about this today, I would have included one. But I thought nothing in nature could be that garish. So I started looking through books to find pictures, and some looked like it, some didn't. Finally, I had a little telescope somebody gave me, and it took me 2 hours to find it. But I finally honed in on Saturn, which sure enough was yellow, with brownish-looking rings. And that was kind of a relief that nothing in the nature could be that heinously ugly. But in searching through all these books, I picked up an interest that I've never really lost.